Latency, throughput, bandwidth. These are three different and distinct performance metrics that describe different behaviors in an AI system. They are often used interchangeably, but each one captures different parts of an AI system's performance. Confusing them will diagnose the wrong problem and make you optimize for the wrong thing. In today's video, we're going to fix that using a product you already know, ChatGPT. Hello, welcome to Tech with James. In this channel, I break down AI concept, jargon, and everything in between through storytelling. Today, I'm going to break down three performance metrics that you've probably been confusing: latency, throughput, and bandwidth. Okay, this video is going to be the last video you ever watch to understand these terms. Come with me. Latency measures the time required to process a single request from input to output. In ChatGPT, latency has two components. The first is time to first token, which measures the gap between the moment you hit enter and the moment the first word starts appearing on your screen. The second is the total response time, which captures how long the full response takes to complete. So when ChatGPT feels slow to respond, what you are experiencing is high latency. The model received your prompt, processed it through its inference pipeline, and took longer than expected to return an output. Latency shows up directly in how responsive and interactive product feels. For a conversational AI product like ChatGPT, latency is the metrics that determines if the experience you have will feel real-time or sluggish. So a 200 millisecond response feels fast, but a 3-second delay before the first token appears feels broken, even if the final output in both scenarios is identical. Let's look at the second one, throughput. Throughput is how many inference requests a system can handle per time. So it is measured as tokens per second across many requests. Now here is what is important. You using ChatGPT at 2 p.m. on a Tuesday is not the same as 10 million people using ChatGPT simultaneously. Your individual experience is a latency problem, but the system's ability to serve 10 million users without degrading is a throughput problem. When OpenAI's infrastructure is under heavy load and responses feel slower across board, that is a throughput constraint. Basically, the system is processing more requests than it can handle at full speed. So some architectural choices that an AI system can make is to introduce queuing and delay. That means the system will batch requests together to serve more users efficiently. But the trade-off is that this would add time to fulfilling each individual request. So this is called head-of-line blocking. And basically, it means that if one user submits a complex task, say summarize a 50-page document, and 9 other users ask just simple questions, all of the 9 users will be stuck until that one user has been responded to. So basically, high throughput systems have to actively manage this problem. The third performance metric is bandwidth. So bandwidth refers to the theoretical data transfer rate of a connection. Basically, the ceiling of what is possible, not what is actually happening. So in the context of ChatGPT, bandwidth matters on 2 levels. So at the first level, which is the network level, bandwidth is basically the capacity of the connection between your device and OpenAI servers. So we're talking about how much data can move per second at maximum. Then we have the second level, which is the infrastructure level. And at this level, bandwidth is the memory of the GPUs running the model. So it's basically checking how fast weights and activations can be read from the memory during inference. Now, I want you to know this: your throughput will almost always be lower than your available bandwidth because of real-world factors. That is why a fast internet connection on your end does not guarantee that ChatGPT will give you fast responses. Essentially, I want you to see this way: bandwidth is the pipe, while latency and throughput, they determine what flows through that pipe and how fast. Now, here is the trade-off. Latency and throughput pull inference architecture in different directions. Optimizing for one performance metric, we almost always introduce pressure on the other one. So if OpenAI, for instance, optimizes ChatGPT for low latency, that is trying to make individual responses fast per second, they would have to reduce the system's ability to serve multiple users simultaneously. But if they optimize for throughput, which is to serve multiple users at the same time, then individual response time will go up. So we have high latency. When you're optimizing for low latency, you get low throughput. When you're maximizing for high throughput, you get high latency. That's almost always the trade-off to make. Now, in 2026, most AI systems are being explicit on what side of the spectrum they want to stay, depending on the user they're trying to serve. So, in summary, latency is how fast a request gets answered. Throughput is how many requests an AI system can handle at once, and bandwidth is the maximum capacity those requests are moving through. So, these are three different metrics optimized for three different problems. So, if you want me to go into deeper technical detail of how product teams are dealing with the latency throughput trade-off, comment infra in the comment section and I'll make a separate video just for you. In the meantime, this is Tech with James, where AI makes sense. If you enjoyed this video, if you enjoyed listening to me break it down, you would love my future and my past videos. So make sure you hit that subscribe button, watch my existing videos, and stay tuned for more videos like this one. Bye!